All right, hello, everybody. In this one, we're going to be implementing Tic-Tac-Toe, and we're just going to make a really simple AI that you can never beat. And we're going to be using C99, and we're going to be using Raylib. Yeah, let's get started. All right, so first up, we're going to set up the project. So I'm going to name it something like C Tic-Tac-Toe. I'm not going to add a description. We'll keep it public, and then it will be in the description down below if anybody actually wants to take a look at the code themselves. And I'm going to be using my Raylib template. It's a little bit differently from the snake version that we had before. Basically, what I did was I changed it so that way it's now using DLLs. So just to show this, we can go into Z. I'm going to go to Projects Games, clone it, then we'll go into C Tic-Tac-Toe. And now we're in here, and basically the way you do it is I'm just using Python for right now. I feel like I should use like C in total honesty. Feels like kind of like sacrilegious to be using Python in a C project, but that's okay. But basically what we need to do is we need to download the DLL we're going to be using, and in this case I'm using Mac, so I set up the Mac version. And then what I can do just for the first build to make my life a little easier, I basically have this thing called firstrun.py, which just basically makes it run. And now we're actually just kind of like good to go. So this is our template project. And yeah, from here we're going to be going to actually implementing Tic-Tac-Toe. All right, so let's start implementing Tic-Tac-Toe. So I'm going to start by changing this. I should change this because I always forget to in the actual template itself. But let's update the naming to be more in line with the style that I like. And then from here, we're going to start by doing scenes, where basically, again, we just basically want to know what scene we're in. So we'll have scene, this, and then the actual values will start with our like scene menu, and then we'll have scene game. We'll make this, right? And then we'll have this right here, scene, current scene. I kind of like maybe just this in all honesty, and we'll just start in scene menu, right? So that seems pretty good to me. And then from there, we need to actually handle the basic logic, right? So again, we just have our scene, and then we can do something like this, and then we'll come back to that in just a second. But let's actually take this and then also update this. And then since I like a dark background, we'll do black as per usual. And then we can actually implement some basic logic for these two real quick. So in this case, basically what we're going to have is we're going to have, well, first we want to do this, then this, right? So we don't forget that. That looks good now. And now we can have basically, I should actually do this too. And then it's just assert false because something has gone horribly wrong. And then we'll do the same thing over here. Our default case, assert false. And then we need to actually include up here, include assert.h. And now we can actually implement stuff. So I'm going to start with the default behavior for scenes, which is just like, we're going to be using our mouse in this game actually, but let's just keep it simple for right now. So we'll just do like key enter just to see things working, and then we'll do scene equals scene game. And then in the game scene, we'll do this, where instead of going to the game scene, we'll go to the menu scene. And then when we get to the rendering over here, right, we're again just going to do this, this. Now we can put this over there. Looks good to me. And then we can just do like some draw text real quick. Draw text, and then it'll just be menu scene for right now, and we'll start at like 100, 140, and then we'll do color black because, oh no, we'll do white in this case, and then in this one, instead of that, we'll do the game scene. So let's see how this works. We can remove our text. So now we can go into build, cmake, build parallel. So that's running, looks good to me. Menu scene, and I think I made it enter, so we have scene switching, which is pretty nice. All right, so now we're actually going to get into making our menu scene a little bit better. And I'm going to start with basically a common pattern I actually noticed when we were implementing CSnake. or just snake, because I don't know why the C really has to be in that right before. But regardless, basically what I noticed was there was this common pattern where we were constantly just centering text, basically, centered text. And so what we're going to do is we're just going to implement a little helper struct, if you will, just to kind of track that. So we'll do this, and then we'll make it center text, right? And then to keep with the naming, it'll be like this. And then basically what it's going to have, we're going to have our char star, and we're going to have our text. Then we're going to have an int, which is going to be the width, or the font size, sorry. Font size. And then the next thing we're going to have is two positions, int x, and x we're going to say, hey, please don't change it. Y is something we're going to ask them to change. And then finally we're going to have a color, which is just going to be like the text color. And they can modify it if they want. And so we're going to use that basically to implement a couple functions. So the first thing is we're going to have static void, and it's just going to be CT, we'll make it like this, why not? Text init, right? And it's going to take in a centered text, CT, and basically there are some things we're going to set and there's some things they're going to set. In our case, char star text is they're going to do it. Font size, they're going to give it to us. X, they're not going to set, but they are going to set Y, and they are going to set the color. Okay, so assuming I definitely made a mistake there. Center text, this should be centered text. And then for some reason I've been typing the reference sign like this is C++. It's not. This is C, so you don't really do references. But anyways, basically what we can do now is we can say CT text is equal to text, right? CT font size is equal to font size. And then what I don't have in here, but I need actually, is I need the screen width, int screen width. And then so with that, we can now measure, right, where this should be. So I'm going to now stop initializing for a second and do, actually, we'll just finish initializing real quick. CT Y is equal to Y, and then CT color is equal to color. And then what we can do is we can say const int W is equal to screen width all minus, oh no, I'm being a little ahead of myself. First we have to measure the text, then we pass in the text, we pass in the font size, looks good, and now we can say CT X is equal to screen width minus W all divided by 2. So there's our center text. And then what we can do as well, static void center text render, right? And then all we're going to do is pass into it basically the center text CT. And then we can do draw text, this one, CT text, CT X, CT Y, CT font size, and then CT color. So we've compressed. This, frankly, is not super necessary, this function, but it does make it a little bit easier on the typing side. Center text render, center text init, that looks good to me. So let's add, now that we have this, center text, menu, title, and then what we can do is center text init, we can pass in menu title. The text is Tic-Tac-Toe. The font size will make it 40, and we can play with it. This will be screen height divided by 4. The color will be white, and screen width, in this case, will just be screen width. And so it's giving me an error right here. And that's not really an error so much as a warning, which is we have a const char 12, but we're using this, and I am okay with it. But we can, if we want to be like this, that is okay. And maybe they have a better suggestion now. They don't, so let's just keep it like that. CMake build dot, nope, there. And then we're not actually rendering. So yeah, oops. Let's actually render now. Instead of menu scene, let's do center text render, and we can pass in our menu text. So we can do cmake this, or this, cmake build, I'm just going to type myself, bin project, and now we have tic-tac-toe, but it is not centered. It looks terrible. All right, so I found the problem with why everything isn't centered. Basically, measure text isn't going to work correctly when I call this. So what I'm going to do is I'm just going to put this right below here. So we basically are declaring stuff and it's doing stuff. And then we can start, after we've initialized the window, then we can measure the text properly when we call this function right here. So theoretically, when I run, I do this, and all of a sudden tic-tac-toe is properly centered. What I don't like about what I just saw was it feels a little small being the font. So let's make it like 60. Make it, run it, and that to me looks a lot better. All right, so the next thing is basically to handle the button, which we're going to use with a rectangle, and it's basically going to be menu start button, let's just say. And then what we'll do is we'll actually initialize it over here. So I'm just going to make some comments like this. Initialize menu. And I'm going to put it kind of like this style right here. So we'll do like this many. And that looks fine to me. So initialize menu, and then I've never really liked that, so I'm going to do it like this. And then we're going to need this later, so we'll do it like this, initialize game. And so now what we have to handle is the menu start button. So menu start button dot x, we're going to make, actually let's handle width and height first. We're going to make it 200. Oops. 200, and then menu start button dot height is going to equal to 100, let's just say. Now let's go back up here, menu start button dot x. Let's say it's going to be, well, we're actually going to be centering it, so we actually need to be a little bit smarter. But the menu start button dot y is going to be equal to screen height divided by 2. So this one is going to be 200 basically, so we'll actually do it like this. It's a little gross, but that is okay. Now we'll put this there, we'll put this there, and then we can do menu, basically screen width minus menu start button, all divided by 2. And now that should be centered, but we're not actually drawing it yet. But so let's draw this thing now. And then we also need, now that I'm thinking about it, color, which will be menu start button color. And the default color, let's just say, is going to be menu start button color, and this is going to just be equal to white. And we can come back to it later. So what we're going to do is we're going to draw in right here. Nope, sorry, we need to keep going down. We should have like a nice little separator right here. So let me actually take this. And then this is going to be update. And then this is going to be drawing or rendering or whatever you really want to say. But in here, we now need to actually draw the rectangle. So we can do draw rectangle, and then we can, I don't like that, draw rectangle rec, right? And then we have the menu start button, menu start button color. So there we go. And theoretically, that'll just be a centered-ish button that looks okay. Nope. Let's figure out this real quick. Menu start button, yeah, dot width, and that'll fix that. Now we can run it. Now we can see what it looks like. And you can see we have this kind of button that we can see is just a rectangle. It doesn't look very good. That's okay. We can make that a little bit better. Now, if I'm not crazy, the first thing I want to check is draw rectangle rounded. Yeah. So let's actually, I don't really, let's just keep it a square. And if we ever want to make it pretty, we can make it pretty. But what we need to do is we need to actually handle some behavior. The first of which is we need to draw stuff so that there's text, which is like play, for example. But we also need to handle like the actual behavior of what happens when we're over it. So what I'm going to do is there's get mouse position. Actually, we need to do, get mouse position, right? And that's going to return a vector2, and we'll call it like mouse pos is equal to this. And then what we need to do is we actually need to handle if there's some amount, if the vector is inside our vector. The vector is inside our rectangle. So vector2 in. I'm sure there's like a, what is it? Maybe it's like rectangle in. All right, so this is what we're looking for. Check collision point rec. So basically what we want to do is we want to say is if check collision point rec, and then we pass in the mouse pos, and then we can pass in the menu start button, right? And if this is the case, we are inside of the button. And basically what we'll do is we'll say if is key pressed, and then mouse left button. And in this case, we will now go into this. Otherwise, what we actually want to do is we want to change the color. So mouse pos, it's kind of like color. It should, what did we name it? It is menu start button. Okay. Menu start button. Color, we'll make it like what will we make it? Make it yellow. Why not? It'll be very garish. Otherwise, right, the color will make it to be just like menu start button. Color is going to be white. And then when we click it, just for funsies, we'll make it red. We'll make it green. We'll make it green. Okay, so let's see what this looks like. So we're over it, we're over it, we're over it. Now I'm going to click it, and nothing's going to happen. But we're definitely have mouse presses. So the problem is mouse button press. So is that the problem? Yeah. Oops, there we go. So we do this. Now I'm going to click it, and now we're in the game scene. So let's actually try the middle button. It works. And then I think I set it to like enter. Right button works. This works. This works. We don't really get to see the red, which isn't really surprising. So we can just get rid of that code, or the green, sorry, because it doesn't actually do anything. But everything else is looking good in terms of the behavior. It takes us to where we want to go. But what we don't have and what we need is the center text for the button itself. So I'm going to add one more center text, which is basically going to be center text, and then it will be the menu start button text. And so like all this, by the way, is pretty much all you need for a button. So ideally, you would just make it into its own struct with its own data points, and then you could use it again. But we're not going to be doing more than one button this game, or at least a button with text, so we don't really need to do that. But anywho, if we have this center text, right, what we can do is we can initialize it. So what we're going to do is we're going to do center text init, and then we're going to pass in the menu start button center text. The text is going to be play. The font size will be 40, but we'll play around with it. The height will be based on the menu start button. Where is it? No, menu start button, and it will be based off of Y. The actual color will make it black because we're dealing with that. And then the screen width, we're actually going to do this right here, menu start button dot width. And then what we're going to do after this is we're going to do menu start button text, and we're going to update the thing we're not supposed to update to be basically based on starting from this equals dot plus equals x. So we're basically shifting it a little bit. Now, this is a little weird because this is x int, and then this is, I guess this is an int. So this should be an int. Okay, cool. So let's see what happens if this actually just works first try. Nope. Oh, that's because we're not even rendering, of course. So now what we can do, and over here, is we can do a centered text render, and then this time it will be menu start button text. And I'm going to put this up here. And you can see the idea worked, but the actual position in terms of Y is a little bit off, but play is centered like we wanted. So we can do a couple things. The first thing is we can make this a little bit bigger. And then the second thing is we can do something like menu start button dot height divide by 2. And let's see how that looks. That's too much, so let's do like a divide by 3. Looks a little bit better, but I still don't love it. Let's do 2 or R4. Nope. Let's see 5. Why not? Just a little bit off, so let's try 4. All right, yeah, that looks pretty good to me. So we now have a little play button, which works exactly like you would hope it would. And we can now get into actually implementing Tic-Tac-Toe. All right, so now we're gonna basically start with the actual game part of this. Right now, all we have is a menu. What we need to add is basically the board for the game. So I'm gonna have this right up here, and I'm gonna have another enum. And this time, what it's gonna be is it's gonna be for the board state. And so what we're gonna have is we're gonna have empty. We'll name it cell, let's say. Cell empty, cell O, and then we'll have cell X for basically the two different kinds of players. We'll initialize this to 0. We'll initialize this to 0 as well. Oops, sorry about that. And basically, we're going to have a grid of these. And so if we go all the way down here now, we know that tic-tac-toe is 3 by 3. So what we can do is we can say cell grid is going to be 9. And that's because we know that it's 3 by 3 or 3 times 3, which is 9. And so what we're going to initialize it to is 0. So basically we know for a fact that that is going to be okay. And the other thing we need to do is handle whose turn it is in the game. And so in this case we can do like cell player turn, right? And then this is a problem because of this. And then what we can do is when the player presses play, basically we'll do grid, and then we'll just set it equal to 0. So we'll do this. I guess we could also do kind of like this for size ti is equal to 0, I less than, and then we'll just do this just for simplicity's sake. At the very top, hashtag define, num cells is equal to 9. Then I can find 9. Num cells, that replaces it, and then we can use that right here to num cells, this plus plus I, this, and then we can say grid I is equal to cell empty. I think another way you could do it if we were being kind of cleverish is we could use like memset, and then we could basically set it to 0 this way. But I think this way is just a little bit more readable. And then the other thing to do here is after we reset our board, we're going to say is equal to, and I think X always goes first. So we'll use cell X. And then we should be ready to actually play the game in terms of our data structures. I think this is actually all we need. Yeah, this is all we need. Okay, cool. So Now that we have our kind of data structure set up, I think the next thing to do is actually get into rendering it. All right, so let's actually start by drawing the board itself. So we're not actually going to be handling the context of the board. I'm just saying let's draw the lines. So when you think about it, we need to draw 4 different lines. The first line is going to be where we're in here, where it's a third of the way into it. The start position is going to be 0. The end position of x is going to actually just still be screen width divided by 3. The end position of y is going to be screen height, and the color will be white. Then if we do one more, because we're still going to be going down, we're just going to do this 2 times. And let's actually see if this worked. So we can go see make build. Nope, we're not pushing. And then we do this, we can play, and you can see now we have 2 lines going down, which is always what we want. Now we need 2 lines going horizontally. So we can just do this, draw a line, and then this time we're going to be starting from 0. For the height though, we're going to be dividing by 3. We're now going across, so we're going to be using width. And then screen height isn't going to change for this, and then we'll use color white. And then we can do this, but instead of doing that, we can do 2 times for both. And now we should have a kind of board, which looks okay. And so there's our board being rendered. And so the next thing to do is actually to handle rendering if we've clicked it or not. So essentially what I'm getting at is if we click this, an X should appear. And then the next time we click, an O should appear. So the next part was actually a little bit more tedious to implement. So I went ahead and just implemented it, and now we can kind of look at the results. And I think the rest will be doing coding live, but this was just more tedious than anything. So basically we created a render texture based on the square size. So the square size is again just like that the board we were just looking at right before. And so basically all we do is we draw 2 circles. The first is we draw a big circle that's white, and then we draw a smaller circle inside of it. This is the radius right here, so divide by 2.8 rather than 2.4. And basically what this does is it gives us the look of an O, and we'll look at it in just a second. And I'll actually get rid of this so we can kind of see. The other one is where we're drawing the X, and this is where we just draw 2 lines where basically we go from 0, 0, so top left, down to the bottom right, and then we just adjust these so X moves over to the right, and then X moves over to the left, and then we get the crisscross effect of an X. And so in terms of the actual rendering code, I added 2 things right here actually. This is in rendering. This is where I just added where we can see X and 0 real quick. And then in terms of the actual rendering code is after we draw these lines, what I do now is I loop through the grids and I get the X and the Y coordinate by basically just doing this little cheat. Another way we could do it is basically the index to board position kind of trick where we'd have to do some mod stuff. But this is just super simple and easy, so I went with that. And then we actually don't need these print statements anymore. Fun fact. But basically we just draw the texture, right? And we do X, which we're defining up here, and we multiply it by the square size, Y times the square size. And then the tint is just white, basically meaning we're not going to change anything about the texture we're drawing. So, and then cell X, we're using the texture for texture X. So when we actually run it, you can see we're going to get this kind of not great thing where this circle is actually wrong. So we can fix it because right now we're not drawing that inner circle to erase the part of the white circle that we don't want. So where did it go? Right here. So now I just fix that, do this, and now we're running again, and now you can see why we have that second circle to call. So now we have this behavior where basically we're rendering the game. Maybe people don't like the fact that we can see this like X occurring right here, which is totally fair. But we can always just fix that later if it's really bothersome. But we have the ability to render the board state. Now we need the ability to actually play the game. All right, so the first thing is I actually forgot to unload our render textures in the previous section, but we want to do that just in case we're worried about memory leaks. And then over here, I'm actually going to just change the whole style of the videos I just decided in between sections where I think it's better just to type it out and then record what happened. So basically, in this one, basically what we're getting at is we want the player to be able to click things and have a result. So we're doing these 3 lines again, left, middle, or right. If the mouse button is pressed, we go into here, And then what we're doing is we're getting the mouse position, right? And I changed it so since we use it twice, it's now here, and I think that's a little cleaner looking actually. But basically we get the mouse position X and Y, and then we divide by the square size. As a reminder, the square size is right here, and basically it's the screen width divided by 3, and we're taking advantage of the fact that we have a square screen that we're working in. But essentially this is just getting the X and Y coordinates in our grid, then we convert it into an index with which we can then access, and then in here we're checking to see if it's empty, and if it's empty then we're able to actually make a move. So the result is basically this right here, where we're in the play mode, we go in here, and I'm just going to click the middle one, for example, and you can see X shows up. If I click down here, then circle, and now you can see we're starting to actually get a game, but what we don't have is the ability for the player to actually win. So let's get to that next. So I made the next set of updates, which is basically we're handling if the player won or lost after they made their turn. And so basically what we're doing is we're checking if game over, and if so, we're going to go back to the menu scene. It's a little gross in terms of the actual player experience, but we can fix this later if we want to. But over here, we have this game over function. And basically, we're also going to make it so we don't change the player turn if the player won. And that's because we can use this information when we're actually rendering some kind of like information like X1 or circle 1 or whatever. So in terms of the game over function, this is all it is. It's basically just we're checking for horizontal and we're checking for vertical wins. It's a little gross to look at, admittedly, but it's also just very simple. The alternative is 2 for loops and then 2 checks for the diagonals. I think this is just a little bit better because people look at it and they can pretty much just figure it out in seconds without actually knowing what these indexes are. It's pretty clear, at least in my opinion, that we're basically just checking for the game over conditions in tic-tac-toe. Now, I think a valid complaint is what if we wanted to do a 4x4 version or whatever? And then, yeah, in this case, we've chosen something that wasn't very extendable, but that is okay. So I'm going to just win as X real quick, and you can see it's over, and now I'm going to win as circle real quick. And, oh, I messed up. Let me restart that. So play, so I'm going to go X circle, X circle, X circle, and then we win a circle. So there's basically the basic functionality of game over working. And now that we actually have this, I think that's all we need to actually get into implementing the tree search AI, so that way we'll basically never win again. All right, so now we've actually implemented the AI, so let's go over it. First, we added this function called grid is full. This is basically where all we're doing is we're checking every cell in the grid, and if we find an empty cell, we return false. Otherwise, we return true, meaning there are no valid moves for the player. And then basically the other thing is we're now checking for the draw case where if the grid is full, we're going to go to the menu scene after the player's turn is over. So in here, so given that, actually we can just change it to else. But anywho, so now that we're in here, we have our grid update with Minimax. We'll look at that in a second. And basically what we want to check is either the game is over or the grid is full. In either case, we're going to go to the menu scene. So let's look at how the AI is actually playing the game now. So what we do is we start with this grid empty indexes. And so the way this works is actually very similar to grid is full, except what we're doing instead is we're finding indexes that aren't filled. So basically what we have is the num indexes, and we're going to fill in this array where when we find an empty cell, we set this with num indexes, we plus num indexes, and then we return that. So basically this fills up with valid indexes, and this is the size, and we return it. So once we actually have that, we can go into our update. So our update starts with basically this, where we update the board to be the current player, which is right there. And then ignoring all this for a second, we do stuff. And then at the end, we reset the board to its original state. And then after we've found this best index, which is going to be right in this code right here, we set it over here, and then we update the board basically at the end of this loop. But what we can do is we can actually check to see if the game is over. Because if the game is over, that means this player has currently won, the player we're trying to make a move for. So obviously the player should make that move. So we use this move, and then we just return, and we don't even have to get to this line of code. But otherwise the player hasn't won, and then we can get into Minimax. So in this case, all we're doing is we're calling this function grid Minimax, where we switch the player because we've updated the board. basically right there. And then before we look at this code, basically we're going to get a score. And the score, we're checking to see if it's better than our best score. We start off with a very negative score on purpose. If it's better, we set best score equal to the current score, and then the best index, meaning the move we made, to be equal to I. We reset, and then we go back to the top. And then at the end, we use the best index to actually set the next grid. Now, looking actually how we implemented Minimax, what we do first is we check to see basically right here is the game over at the current cell or grid that we're at? And if so, basically what we do is we check to see if it's O, and that means it's the opponent over here, then it's 1, otherwise we return -1. So next we can actually look at this part. This is where kind of like Minimax is actually working, where we're recursing through all the possible states of tic-tac-toe. So we have our score, we have our indexes, and then we get our empty indexes. Hopefully pretty simple. We now check for a draw. So this is basically exactly what we do with grid is full, except since we already have to do this work, we don't just do it twice, we just check to see if there were no empty indexes, we have num indexes equal to 0, then we just return 0. Otherwise, we have these two different cases. This is where the term minimax comes from, right? In one case, we're minimizing, and in one case, we're maximizing. So in the case when we're the player and it's circle, so that's the AI who is circle, what we're going to do is we're going to try to maximize our score. And again, our score is based off of this right here, where basically we're trying to get the most positive score or most positive board wins. So what we do is we set it, we reset it, the same exact logic when we were over here where we set the grid and then we reset our grid so we had a valid state. And then what we call max on grid minimax, where we switch the player. And then in the other case, when it's X over here, so that means the player's simulated turn, we're calling minimize instead. And that's all there is to Minimax. It's a pretty simple algorithm. It can get very expensive if we're playing a game with a larger board state, like say tic-tac or chess, for example. All of a sudden Minimax isn't really going to work because you can't get to the maximum depth. But if we're in a very well-known state or well-known board, I guess, basically the search space is very small. Minimax can work really well. So I'm just going to play it, and you can see we went back because it was a draw. I'll go here, 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 and you can see it's blocked everything. So Minimax is actually working as we hoped. And this is actually a full game of tic-tac-toe. Now, I do want to make a couple changes before we call it finished. Specifically, I basically want to just add something to basically tell the player if they won or lost. Or maybe it may be interesting, for example, if I went here to like highlight these 3 circles real quick, like so. So, and that's actually a bug right there where basically this should have put us into basically the menu state again. So there's a bug to fix, and we're also just going to make the game a little bit prettier in the next 2 or so sections. All right, so the bug basically was right here. Originally, I was using player turn, right? And that was using this, wasn't using the AI's player, it was using the current player, which was X. So what I did was I just changed it to cell O, and then all of a sudden this just works. And then the other thing I did was I added this right here. So I'm using this m sub I, and basically if we go to the definition for a second, you'll see that this was originally in the game right here, but I moved it to the top of the update loop, where basically I get the mouse position and then I use it to calculate m sub x and m sub y. Basically this is the mouse x position in our grid, mouse y position in our grid, and then I use it to calculate the index into our actual grid. And if it's empty, then I actually highlight that cell, basically telling the player you can go there. So when you look at it, now we have this little blue thing, and if I press this, you can see we actually get a result. And now we're there, and now we're there. And then just to show the fix, right, I'm going to just show this, and then I'll show this, and you can see the AI won, and that is that. Now the last thing I want to do before we call tic-tac-toe done is basically add some kind of indication to the player that the game is over. All right, so this is the function that we're going to use to be able to draw a line across the screen, basically to tell the player how they lost. Because we're using Minimax, they're never going to win, but technically this could also be used if they won. So if, for example, someone came along and was like, make a video about how to make different AIs, then this would also still be usable. But regardless, we use the screen size to basically get the square size, which we've already done. This is checking for diagonals, both in this one as well. And basically, this is exactly what this is, except way more verbose. And we're also using it to be able to figure out where we need to draw our lines. This is when we're handling the rows, so vertically or horizontally, sorry. And these are columns, so this is when we're going vertically. So this is how we're figuring out where to draw our lines, and then we just do a return once we found it, because we know there's not going to be multiple ways to draw a line. So with that, we had to make some updates, which was, for starters, basically, we needed this right here, where I added a game over frame count. So this is going to be basically for how long we're going to be showing the lines for how the player lost. And these are the two lines or vectors that we're going to be drawing to. So this is where the line starts, and this is where the line ends. So I added a little bit of a big comment there, and then over here you can see I set the game over frame count equal to -1. So when it's -1, that means the game is not over, the player is still playing. But once we get over, I'm going to skip this for right now, but basically if it's greater than or equal to 0, that means the game is over. And if that's the case, what we do is we check to see if we've gotten to 120. If we have, we go back to the main menu. So this means it runs for 2 seconds. It's a little long. Maybe we'll actually go down to like 100 seconds. Not 100 seconds. 100 divided by 60 seconds. So 10 divided by 6, 5 divided by 4, 1.2 seconds. So plus, and then otherwise we're just gonna plus our frame count, and it's just gonna keep incrementing until we equal this. Otherwise, I had to change our logic just a little bit, where in the first case, the game is over, so we're gonna update our frame count to be equal to 0, and that means this is gonna start running when we get to the next update loop. And then otherwise, there's another case we need to handle where the game is over because it's a draw. And in this case, we set game is equal to, the game over frame count is equal to 0, but now we actually update the player turn to be cell empty. And so the reason why we're doing this is if we go down into our draw logic, we have two cases basically where we're going to call this draw line where we're using game over line start and game over line end, and then we make it thickness 10 with a red coloring. The first case is that we're going to draw it when the game is over, meaning that game over frame count is greater than 0. It should be greater than or equal to, actually, given our logic. And then the second thing is we're only going to draw a line if this player turn is not equal to cell empty. So basically meaning if player turn is equal to cell empty, that means it was a draw and there's no lines to draw. So going back up, basically this right here is, oh yeah, so this is basically making it so that way we don't draw our little highlighted rectangle if the game is over. So we're only doing it when the player is playing, which is why we do less than 0. And then finally, we have the AI logic, and it's the exact same kind of logic of this one, where basically we check grid game over. If it is over, we set it equal to 0, and then we can update our lines. But if the grid is full, that means we have a draw again, and then we basically set this equal to 0, and then we're good to go. So let's look at this running. I'll build it just in case. And now you can see we have our game of tic-tac-toe. I'm going to try and win for a second. I'm not going to succeed, but that is the game, and you can see nothing is really showing up. We go back to the main screen. We press play. I'm now going to lose on purpose, and you can see we have a nice little line drawing, and that is tic-tac-toe. There's definitely more that could be added, right? We could add, for example, more AIs to the game. We could add a 2-player mode. There's a lot more we could do. We could also make it a little bit more general, so you could play circles or X's. But at its core, this is tic-tac-toe with Minimax. So yeah, I hope you enjoyed the video, and I'll see you in the next one. Bye.